Okay, let's take a look at question number 2 from homework 8. Before you watch this though, if you are at all confused about what these questions are asking for, I encourage you to watch the video that I made about what all these things mean. What does it mean for a function to be increasing? How do we figure out if a function's increasing? What does it mean for a function to have a relative maximum? How do we find this relative maximum? Those are all things that I kind of cover in the overview video, so if you're not sure about it, sometimes it helps to have a good picture of what's happening in your head so that you can answer these questions a little better. Go back and watch that video and then come back for this one, and I think it'll make a little bit more sense for you. So for number 2, they're asking us to find the interval where a function is increasing and the interval where it's decreasing, and they're giving us the function f of x equals 5 minus 8x. So step 1 is going to be to find the derivative, because if we want to know where a function is increasing or decreasing, we need to know what the slopes of the tangent lines are at different places. So we're going to have to take a derivative, because derivatives, when we plug in x values, give us slopes of tangent lines. So step 1 is to find the derivative. Okay. Step 2 is going to be to find 2 things. And in this case, we're only going to have to find one of them, but we need to remember what we need to do. We need to find where f prime of x equals 0. And then we also need to find where f prime of x doesn't exist. So that's step 2. And we're going to have to do one or the other of these pretty much with every question that we come up with today. So let's make sure that we keep that in our list. And then 3, we're going to need to check values of x. So we'll check x values around the points that we found in step 2. All right? All right, and the reason we're doing that, let me pull out a picture here so that we can see that. If we find places, this is the picture from the first video, if we find places where the slope is equal to 0, where f prime equals 0, then we know that if we check, if I find this spot here, if I find a place where x is equal to 0, and I check values of x that are lower than that, they're going to give me a positive number for my answer because my tangent line is positive here. So even if I didn't know what was happening, if I knew that there was a place where my f prime equaled 0, that I had some kind of maximum or minimum happening there, if I plug in numbers to the left and I get positive numbers, that tells me that the function's coming up to that point. If I plugged in numbers on this side, whoops, let's cover it up. If I plugged in numbers on this side of it, then I should get a tangent line that's negative, right? Because it's sloping downward. So we're looking, when we set it equal to 0, what we're trying to do is find the points where that tangent line is completely horizontal and then check around it to see what's happening. Is it going up? Is it coming down? You know, is it going up? We're going to try and figure that out, and that's going to tell us where things are increasing and decreasing, okay? So let's do step 1. We've got f prime of x, or f of x, we need to find f prime of x. So for our step 1, f prime of x equals, well, the 5 goes away, and then the derivative of negative 8x is just going to be negative 8, okay? And here's where, for the first question on the homework, they're being kind of tricky for you. So step 2 says, find where f prime of x equals 0. So I want to set f prime of x, which is negative 8, equal to 0. Is that ever going to happen? Is there any way that negative 8 is ever going to equal 0? If I had an x in there somewhere, maybe, but it doesn't have an x, so it's never going to be equal to 0. Never equal to 0, okay? Is there any place that this function doesn't exist? Like before when we had like zeros in the denominator? Do we even have a denominator for things to not exist? No. So negative 8 always exists. All right? That function always exists. There's no point where it doesn't exist. -8 is -8 forever and ever and ever. Okay, so let's see. We don't have any x values to check now because we didn't find any points, but what we do know is that the slope of this function here, because we got this derivative, which tells us the slope of the tangent line to this function, anywhere I check, anywhere on this entire function that I check, the slope is going to be -8. And what does a negative slope mean? A negative slope means that the function, so we have a negative slope, which means the function is always decreasing, all right? It doesn't matter what x is, this function is always decreasing. And if you wanted to kind of draw a picture of this function, you could, and you would see that, because what this function looks like, if I kind of try to draw it out really quickly, I know that my y-intercept is going to be at 5, and I know it's got a slope of -8. It's just a straight line down, okay? So since it's just a straight line down, it's always decreasing. So that kind of makes sense. I did the math and checked it, and it's never equal to 0. The function always exists, and the slope is always negative. That means the function's always decreasing. So the math works out. The picture matches up what the math says. So I think that we're pretty confident at this point that the function is never increasing. So when they ask you which interval it's increasing over, you're going to choose no interval because it's never increasing. And if they ask you where it's decreasing, well, this thing is decreasing everywhere. So you're going to say that it's decreasing from -infinity to +infinity. Okay? And I admit, this one's kind of tricky because you have all of these steps, but you don't know how to use them because you don't have anything to plug in for x. That's where you kind of have to use common sense and think about it a little bit. That if the slope is always -8, that means the slope is always, the actual function is always decreasing. And so that's how we come up with that. Trick question, I get it, but the next few are probably going to make a little bit more sense because we're going to be able to apply our rules to it a little bit better. So start with a function, take the derivative. Figure out where it equals 0. It never equals 0. Figure out where it doesn't exist. It always exists. Check values around the points you found in step 2. Did we find any points? No. So whatever's happening is happening on the entire function. And we see that we have a negative slope for the entire function. And that means that the function is always decreasing.